is just asking 1a. What's that wanting? Well, that's just function notation. And to figure out g of -9, what does that mean? It means plug in -9 for my input, huh? So I'm just going to take my g function there, and for x, I shall replace it by -9. So 2 times -9 plus 5 is what we're going to need for 1a. So it's -18 plus 5. Hey, that's -13. Okay? Now, what we saw was, yeah, we could also, on 1b, we could then input expressions like m minus 4. So this is saying for f, we're going to input m minus 4. And so wherever there's an x, I'm going to put m minus 4. So that'd be m minus 4 squared. Minus 3 times m minus 4 minus 10. And so square that out. M minus 4, that's going to be twice. So it's going to be m squared minus, what, 4m? You've got to FOIL that out. Minus 4m plus 16 when you FOIL m minus 4 twice there. And then we also have minus 3m. Distribute your minus 3. And then minus 3 times minus 4 is positive 12. Minus the 10. And so combine the like terms. You got m squared minus 4, and minus 3 is minus 11m. Does that sound right? And then plus 16 plus 12 and minus 10 is 18. M squared minus 11m plus 18. How's that look? Okay. All right, now the next four are something a little bit different, something we haven't quite seen before. On 1c there, notice this is operations on functions is what these next four are, because really what we're doing is we're combining functions. And the good news is 1c is very, very easy, because what that's asking there is got f plus g. All I'm going to do, yeah, is I'm just going to add the f of x plus the g of x together, meaning the expressions that are f of x and g of x. So I'm just going to add, right, f of x is x squared minus 3x minus 10. I'm just going to add to that g of x, which is 2x plus 5, meaning just combine the like terms. So that would be x squared minus 1x minus 5. Combine the like terms. Okay? Yeah, so you can combine functions. We did get to talk about that, but that's all you're doing. Just adding. This is saying add f and g. What's d wanting? Well, d, I'm wanting subtract, right? So I just subtract. Now, the thing of it is, f of x is, so I'm going to do f of x minus g of x. And so f of x is x squared minus 3x minus 10. And then minus g of x, the thing of that one is, since it's minus g of x, that's going to change that to both of those to minus. You've got to change those signs. So it's x squared minus 3x minus 10 minus 2x minus 5. And so that's x squared minus 5x minus 15. Okay? All right. Now, one other note, quick note, and that's kind of what we're going to do on E anyway, but also please note that x is the input, but this is function notation. X is the input value, and so I could also put in any x value that I wanted to. For example, here I could say do this f minus g of x, but say the x is 2. I could do f minus g of an input value like 2. And so what that would mean is, yeah, just plug in x to be 2 here in place of x. So that would be 2 squared minus 5 times 2 minus 15. It's just the function notation. 4 minus 10 minus 15, which would be negative 21. But anyway, E, I do have that. Now, E, I also have a different thing altogether. The two things, the F and the G, are kind of combined a little different way here, kind of nested, I guess we might say. But what this means, this is called a composition. What this means is, and as you know, you do what's inside first, right? And so what would I do first here? Well, I'm going to do the first thing inside here, which is G of 7. G of 7, do that first. G of 7 means plug in 7 for G. 2 times 7 plus 5, that would be 19, wouldn't it? And so what then I have in E is then F of G of 7 is 19, so don't I have F of 19? Do the G of 7 first to get 19. So I want to do F of 19. And so that would mean plug in 19 for X in the F. So I do 19 squared minus 3 times 19 minus 10. So when they're nested like that, you just kind of work your way out. Do the inside part first and then plug that in and do the other. Let's see, 19 squared, 361, thank you. 3 times 19 is 57. And then minus 10, so I'll wind up with, it'd be 304 minus 10, 294. Okay. All right, so E, I get 294. Now, on F, the little added thing here is on F, I don't have a function value actually to plug in. I don't have an input value to plug in. For, in this case, I want to do F of X first. So in that case, since I don't have a value to actually plug in, for F of X, I just go with X squared minus 3X minus 10. So this would be G of X squared minus 3X minus 10. You see that? Since I don't have a value to actually compute there, I just put in what I can, X squared minus 3X minus 10. All right, well, that turns then into one like B up there, right? Now it's just saying input X squared minus 3X minus 10. So this is going to go in for X in my F function. So that would be 2 times X squared minus 3X minus 10, because that goes in place of X there, plus the 5. With me? See that? I just plug this in right here for the X in the G. So that winds up being 2X squared minus 6X minus 20 plus 5. And so just combine the like terms. 2X squared minus 6X minus 15 is what I wind up with. Okay? So it's just a little bit different combination of functions. It's called the composition. Any questions or concerns on that?
On that last one, if it'll factor, do you want us to factor?
Do I want you to factor on it? That one you don't have to. If you do, it's not, would not be wrong. It may factor, I don't know, but you don't have to. I would just leave it like that. Now, G, part G, is another thing we did with functions, and that was find the zeros. How do I find the zeros of the function? Well, the zeros of function f would be where the function, where f of x equals 0. The 0 part of a 0 is where the function value is 0. So that's what I do. I go up here to f of x, and I set f of x is f of x is x squared minus 3x minus 10. And so when I'm trying to find the 0, what I zero out is f of x. 0 for f of x. And that usually sets up a nice little equation that you should be able to solve. Well, we solved that one. This is where I would factor, right? A little factoring here. Minus 5 and positive 2 to get minus 3x in the middle. So then I set each of those equal to 0. Factors equal to 0, and those will be my zeros. Add 5 and subtract 2. Those are the zeros. All right? All right, so continuing the zero theme here, find the zeros using synthetic division. All right, when we get a bigger function that we cannot factor, we're not going to be able to factor easily just by looking there, I don't think. We're not going to be able to factor that x cubed plus 5x squared minus 2x minus 24. So remember what we did. We used a little synthetic division here. And we started with, remember synthetic division is where we put a number here to divide by. This way I made it look anyway. And then I'm going to divide that number into the coefficients here. Just use the coefficients. 1, 5, negative 2, and negative 24. I'm going to synthetically divide this function's expression by some number. Now, the question is, what number do I use here? What are the potential numbers? Remember? Well, the potential numbers, remember, I look at factors of 24, or negative 24. What factors could I potentially have of 24? Well, I could go with either plus or minus 1, or plus or minus 2, or plus or minus 3, 4, 6, 8. There's a bunch of them. I don't think I'll have to use all those, but those are the potential factors I could have to use there in the box. I don't think it's 1, so I'm going to skip 1. Let's go to 2. So I'm looking here. Let's try 2. I don't know if it'll work or not. But 1 doesn't look like it'll work, so I'm going to skip it. All right, so I tried 2. Well, synthetically divide there. So I've got bring down the 1. Remember how to do that. 1 times 2 then is 2. 5 plus 2 gives me 7. 7 times 2 is 14. We did the, hey, look at that. Good guess. Yeah, because here's what I'm looking for. Maybe I should have tried 1 because 1 would not work. 2 does work because why? How do I know it works? Because I got the 0 remainder. To be a 0, you have to get this 0 remainder. So 2, I'm saying now. So 2 is a 0 because the remainder is 0. So I'm looking for those that have remainder 0. Now, the good news is I don't have to do this again because, look at this. What this tells me then, 2 is a 0, but I've also got a couple of things. This right here, what about that? That would be 1x to the what? 1x squared, because I go 1 less power than I started with. 1x squared plus 7x plus 12 is significant because, what about it? It's a factor, yeah. Not only is 2 a 0, but this is a factor of my thing. And so if I set it equal to 0 and factor it, set that quotient I get, set that equal to 0 and factor it, that gives me my other zeros. 4 and 3. So that'd be negative, set that equal to 0. Yeah, so I get negative 4. Those are my other two zeros, and negative 3. So I've got 2, negative 4, and negative 3. Those are my zeros, which notice those are all on the list there. Yeah, should be on the list, and they are. Okay? So we did those that way. Okay? All right, well, we did quite a bit of graphing, and so let's review a couple of things here on number 3. Number 3, what type of functions do I have there? Quadratics. And what do I know about the shape of quadratics? These are x squared. And what shape? They're parabolas. Okay? So I've got myself a couple of parabolas. The reason I do 2 of them is because the two are in different formats here. On A, I like to call this vertex form of the parabola because I can read the vertex right off of that equation there, can't I? What's the vertex of this parabola? Well, remember it's HK, and so that in this case this is the H, 3, and that's the K, 4, and remember the H is the opposite sign of what you had there, so that's why I went with positive 3. So I've got a vertex of 3, 4, and then I also know from just that equation there, this opens which way? Opens down. And that's because the A is negative 2, so it's going to open down. All right, so I've got 3, 4. Right there's my vertex. And it's going to open down. Now, what I suggest there is just maybe do a couple of points around that. Maybe get x's 2 and 4. See what you got. Let's see. Oh, yeah. The other thing, which that would be what? Negative 2 times 1 squared is 1 plus 4, so that would be positive 2. 2, 2, and then 4, 2. Also, that's what you get, I believe. So those are a couple of good points. And the other thing I'd mention is the y-intercept. Just we know a lot about it because we did that one a lot. Yeah, you might want to find the y-intercept here. The y-intercept, how do we get it? Too far. Set x to be 0. Yeah. Sorry about that. Set x to be 0. So that's always a good one to find also. Negative 2, 0, negative 3 squared plus 4. So that'd be, what, negative 2 times 9, which is negative 18 plus 4. So I'm going to get negative 14. And then also by symmetry, I know there's another one about the same distance away over there. All right, from the vertex. So yeah, those give me several points to grab. Okay, that's how we did those. All right, letter B, 3B, is a little different format. We do know that opens upward because the A here is 1, and so yeah, that one's going to open up. How do we get the vertex of such a one as that? Well, one way we did it was with the formula. The H formula there. What, in this format, what is H equal to? Remember? One thing you might want to remember. It's negative b over 2a. The H of the vertex is going to be negative b over 2a, which in this case is, b is 4, so it'll be negative 4. A is 1, so that'd be 2 times 1, so that's H is negative 2. Then the K, how do we get the K? Well, the K, then we just plug in negative 2 for the X. And so that's going to be, what, 4 minus 8 minus 5, which is negative 9. All right? So that's my vertex, negative 2 and negative 9 vertex. Right along about there. Okay. I think on these also what we did was, we did the y-intercept. Y-intercept is very easy on this one. Set x to be 0. You got 0 squared is 0. 4 times 0 is 0. So you got negative 5. Y-intercept's negative 5. We also did the x-intercepts on this one. Probably asked you to do that. The x-intercept, you said f, the function value equal to 0, y equals 0. And so, yeah, it's just another, did a lot of factoring. This is just another factoring. Be x plus 5, x minus 1. And so my x-intercepts are going to be negative 5 and positive 1. yeah, that's pretty good points there. You can get some more with the table if you want. Okay, not my best parabola ever, but okay. Question or concern? Page number 2. Oh, okay. On number 4, we're referring back to the function in 3a because one of the other things probably get asked about on this final is domain and range. So let's talk about that. Maybe it's been a while since we did talk about domain and range. What do I mean by domain and range? Domain is what? It's the x's, right? It's a set of x values, potential x values. And in other words, well, in the x's, we're looking, is there any restriction on the x's? And in this case, there's not, right? Because the x's can be anything. I mean, to get an x value of -10, it's going to have to be real far down on the graph. But you can use an x value of -10, so that's all real numbers, or negative infinity to positive infinity. X can be anything. What about the range? Well, the range is the y's, the outputs. And in this case, there's a little more restriction on the y's because, yeah, if you look at the y values, you don't have any y values above what? What is that? 4. So the y values only go up to a certain level, and that is 4. You don't have y value of 5 or 6 on this graph. So I would say, what would you say? Negative infinity to 4. Yeah, you can go anything negative you'll have, but only up to 4 positive. And you would include the 4. So that would be your range. So don't forget about domain and range. All right. Number 5. Ball is thrown directly upward. The height of the ball after x seconds is given by the function y equals 55 plus 44x minus 16x squared. Find the maximum height of the ball. Well, this also, really think about the graph here, and this goes right along with the functions we're talking about here, because what shape graph is that? It's a parabola. Yeah, it's an x squared, and its a here is -16, so it's a parabola that opens down. I'm not going to actually graph it, but I'll just say, yeah, it's a parabola that opens down. Where's the maximum? It's at the vertex. So I'm finding the vertex here. If it asks for the maximum here, I'm looking for the vertex. All right, well, it's one of those again. How do I find the vertex of that? Well, I'll use my vertex formula. H equals minus b over 2a. Now, this one's out of order, so to speak. The b here is 44, so it's minus 44 on top. What's the a, though? -16 is the a, yeah. The a is what's times x squared. It's not necessarily what's first. It's a is what's times x squared, so the a is -16. So you got -44 over -32, which is... Divide that out, what? 1.375? And so then the k, plug in that for the x, so we have 55 plus 44 times 1.375 minus 16 times 1.375 squared. All that, plug that into my calculator here. Somebody got it? $85.25? Now the question is, which one of those is the answer? Because it's just asking for the maximum height. Well, it's the k value, right? The height is the y. The k value is the y, so this is the maximum height. So 85.25 feet. The 1.375 is the x value, which is the time to reach the max. you want to know. But the actual max is 85.25. Okay? All right. Number 6, well, we've got another data set there. Do a scatter plot and draw the line of best fit and determine. All right, so we did these way back when, but let's go through it once again. Scatter plot, they're just wanting you to, plot the data. We've got everything's up in the first quadrant there. So X is the year, and Y is going to be the life expectancy. All right, so 1920. All right, so we're using 0 for 1900, so that would be 20, 30, 40, 50, and 60, all right, for my X's. And then my life expectancy, well, I'm going from 54 to 69. How about we start with 50 and then 55, 60, 65, 70. Something like that. All right, so this is my life expectancy in years, and this is my year, where 0 goes to 1900. Something like that. So label, be sure to label. We'll be checking for labels. Okay. All right, so 20, we go with 54.1. 30 with 59.7. 62.9. 68.2. Yeah, these are going up nice and linearly, looks like to me. Yeah, they pretty much follow a line, so it's going to be easy here to draw a line. But yeah, remember what we did was it says draw the line of best fit. We're just going to pick a couple that kind of go through the middle. And so, like I said, these are all lining up pretty well. So let's just go with the first point and the third point. So the 20 and the 40 point is one I used. So ones I used was 20, what was 20? 54.1, and the 40, 62.9. That was my line points, okay? So that's the line of best fit. Now what else did it want us to do? Determine the equation for this line. So how do I determine the equation for that line? Well, that's why I wrote those points there, because what I want is, y equals mx plus b. And yeah, we mentioned this earlier. I do that by getting the m first, right? M is going to be the difference of the y's, y2 minus y1 over x2 minus x1. So I just do difference of the y's or difference of the x's, 62.9 minus 54.1. Divide that by 40 minus 20. And I get, was that 8.8 divided by 20? Does that sound right with my points there? So that's 0.44. So my m is 0.44. So I've got y equals 0.44 x plus b. Now to find the b, this way, you just plug in an x and a y. So x is 20, y is 54.1. So that would be 54.1 equals 8.8. Back to that, I think. Subtract the 8.8, and so b, by my calculations anyway, is 45.3. With me on that? So the equation here I get is y equals 0.44x plus 45.3. Anybody else okay with that? Does that look okay?